I'll be doing group work 14. In this problem it states, Overfield and Klomber, 1980, published the following data on the incidence of tuberculosis in relationship to blood group for a sample of Eskimos. In this group work, we will investigate whether or not this data provides evidence of an association between TB incidence and blood type. Here's the data, and here's the table. And I will be doing problems 1, 2, 3, and 4. In question 1, it says, state the appropriate null and alternative hypothesis for a test to determine if there is a relationship between TB incidence and blood type. So in this case, our null would be that the TB incidence and blood type are independent, and our alternative hypothesis would be that TB incidence and blood type are not independent. Question 2 asked, if TB incidence and blood type are independent, how many type B Eskimos should we expect to have moderate advanced tuberculosis? So we have, in order to find the expected value, we already, there is actually an equation for it already, and it's pretty much expected value is equal to the row total times the column total, and you divide that by the total of everything. So if we're trying to find how many type B Eskimos should we expect to have moderate advanced tuberculosis, then we would need to multiply the total of the Eskimos, for the moderate advanced, 28, and we would times that by the total of B, the B blood type, and we would get, and in fact we would get about 6.18 Eskimos. So that would go into into the parentheses. Basically, in this table, the parenthesis, whatever the number that's in the parentheses is the expected value. So, and in question 3, it says calculate all missing expected cell counts in the table above. As you can see, there were 3 values that I highlighted in red. Those are the ones that were missing. And in order to find those, we just need to repeat the process that we did in problem 2 in order to find those missing values. So 85 times 18, divide that by 249 equals 6.14, and that was to find the expected value for minimal and AB type blood. And 136 times 89, divide that by 249 is equal to 42.52. And that is for not O-type blood and not present. Question 4 asks, why might we have reason to doubt the application of Pearson's chi-squared test in this particular situation? Basically what I put was that there are 2 assumptions. There are observed counts. Observed counts are based on data from random sample. And 2, sample size is large. All expected counts are at least 5 rows or columns of the table with satisfactory expected counts.